All right, welcome back to our unit on chemistry and measurement. Today's topic is density. Okay, it's lesson 4 of 4, our last lesson for this unit. Our objectives are as follows. Okay, today you'll learn two methods for determining the volume of an object. You will understand how the density equation is derived. You'll gain a conceptual understanding of density. And finally, you'll learn how to calculate density given mass and volume. Okay, so for your quick write, okay, remember the quick write's just to get you thinking about today's topic. In 1 to 2 sentences, answer one of the questions below on your notes, okay? On a molecular level or atomic level, what do you think density is? Okay, when you get an x-ray at the dentist's office, why do you think they place a lead vest over you? Okay, consider the 3 blocks below, an iron block, a wood block, and a styrofoam block. Which one do you think is the most dense? Okay, imagine the dots represent the atoms or molecules that make up each block. Which block are the atoms more compact? And in which block are the atoms more spread out? Okay, go ahead and pause this while you do your quick write. I'm going to move on. Okay, so density here. Recall the relationship that exists between mass and volume. Okay, mass is the amount of atoms or molecules that make up an object. Okay, and volume is how much space an object takes up. By comparing the mass and volume of an object, you'll be able to grasp, okay, the concept of density. The more mass an object contains in a given space, the more dense it is. Okay? So density measures how tightly matter is compacted together. Okay, and matter is made up of atoms, molecules, and subatomic particles such as protons and neutrons. Okay? So, consider the 3 cubes or blocks to the right here, each made up of a different substance. Okay, one cube is made of iron, one's made of wood, and the other made of styrofoam. Okay, now let's imagine the dots in each cube represent the arrangement of atoms or molecules in each substance. Okay, notice some of the atoms or molecules are more spread out, and some are more compact. Okay, so density measures how tightly matter, atoms, or molecules are compacted together. Based on this definition, which of the 3 substances do you think is the most dense or the least dense? Take a second, look at the 3 cubes here. Okay, which one is the most dense and which one is the least dense? Okay, well, if you picked iron as the most dense, you're correct. And if you chose styrofoam as the least dense, you're also correct. Okay, so for your notes, what is density? Question on the left-hand side, answer on the right-hand side. Okay, go ahead and pause this while you write. I'm going to move on. Okay, so practice on your notes. Write the question over here on the left-hand side, okay? And the answer goes on the right-hand side of your notes. So go ahead and pause this while you do this. When you're ready to see the answer, okay, go ahead and hit play. Okay, so the leadfish is the most dense because the atoms or molecules, okay, are more compact. Conversely, the woodfish over here, right, is the least dense because the atoms or molecules are more spread out than the clay one and the lead one. Okay, so hopefully you got that right. Okay, so calculating density. Remember, the density compares the mass of an object to its volume or size. Okay, so density is calculated as a ratio of an object's mass to its volume, shown in this equation. Density is equal to mass divided by volume here. Okay, and in the above density expression, mass here, okay, is measured in grams, abbreviated by lowercase g, and volume is measured in either centimeters cubed, abbreviated cm, okay, cubed, and volume is measured in milliliters here, abbreviated ml. So volume is measured in either centimeters cubed or milliliters. Okay, so for example, let's say we would like to find the density of the iron cube. Okay, first we need to determine the mass of the iron cube. Okay, to do this, we could place the iron cube on a scale that measures in grams. Notice the mass here is equal to 62.4 grams. So the iron cube has a mass of 62.4 grams. Okay, now that we have mass though, we still need to find the volume of the iron cube. The volume can be calculated two different ways. Okay, we can measure length times width times height. Okay, so we can measure length here, okay, times width times height, okay, which gives us a volume of 2 times 2 times 2 of 8 centimeters cubed. Okay, so that's one way we calculated volume. Length times width times height. Since it's a cube, we can measure it that way. Okay. Another way we can measure the volume of the iron cube is by water displacement. Notice the initial volume of water in the graduated cylinder is equal to 32 milliliters. Okay, what do you predict is going to happen to the water level if the iron cube is dropped in the graduated cylinder? Okay, that's right, it's going to increase. But by how much? Well, let's find out. Okay, so notice the water increased from 32 milliliters to 40 milliliters, which means the water was displaced by 8 milliliters and the volume of the iron cube is 8 milliliters. Okay, so the volume of the iron cube is equal to 8 milliliters. Okay, now that we have both mass and volume, we can calculate density. So if you recall, we obtained a mass for the iron cube on the scale of 62.4 grams and a volume of 8 milliliters. Okay, if you further recall, density is equal to mass divided by volume. Okay, so plugging our values into our density expression, we get, okay, our mass, our volume. Okay, so the density of iron here is 7.8 grams per milliliters. Okay, so for your notes, how do we calculate density? Question on the left-hand side. The answer here goes on the right-hand side. Go ahead and pause this while you write. I'm going to move on. Okay, so practice. Write this question down on the left-hand side of your notes. Try to figure it out and do your calculations. Okay, when you're ready to check your work, go ahead and hit play after pausing this. Okay. Okay, so answer here. Check your work. See how you did. All right, so density is equal to mass divided by volume. The mass is 1.6 grams. The volume is 3 milliliters. Okay, 1.6 divided by 3, and we have a volume of 0.6 grams per milliliters. Okay, so this brings us to the density of water. Why is 1 centimeter cubed equal to 1 milliliter? Well, one of the nice things about the metric system is that the density of water is equal to 1 gram per milliliter or 1 gram per cubic centimeter. Okay, to illustrate this point, let's say you want to find the volume of this cube. Okay, to do this, we need to measure length times width times height. Length, okay, times width times height. Okay, what's the volume? Well, 1 times 1 times 1. Well, 1 centimeter cubed. Okay, now let's imagine this cube is completely empty. There's nothing in it. Okay, how much water would it take to completely fill the cube? Well, okay, 1 milliliter of water. That's right, 1 milliliter of water fills up 1 centimeter cubed, or 1 milliliter is equal to 1 cubic centimeter. Okay, that is why 1 centimeter cubed equals 1 milliliter. Okay, so the density of water. Now let's find the mass of 1 milliliter of water. Okay, let's put our water cube on the scale here. Okay, turns out 1 milliliter of water weighs 1 gram. Well, that's nice because, okay, notice 1 milliliter of water has a mass of 1 gram. So calculating the density of water, we get, well, 1, okay, plugging in our volume, okay, we get 1. 1 gram divided by 1 milliliter, and the density of water is equal to 1. Okay, well that's nice because objects with a density of greater than 1 will sink in water, and objects with a density of less than 1 will float in water. Okay, so let's come back to our 3 cubes here. Okay, remember the dots represent the molecular arrangement. Okay, notice the densities of each substance, wood, styrofoam, and iron here. Wood has 0.6, styrofoam block is 0.01, and the iron is 7.8. Water density is 1.0. We just learned that. So which objects do you think will float? Remember, objects with a density of less than 1 will float, and objects with a density greater than 1, okay, will sink. Okay? Based on the densities, try to predict which objects will float and which objects will sink. Okay? All right, let's see which objects sink and which objects float. Okay, our wood. All right, well that worked out good. It has a density of 0.6, so it should float, right? So our iron had a density of 7.8, so it should sink straight to the bottom because it has a density of greater than 1. Okay, styrofoam, 0.01, well, it floats, okay? So there you have it. Objects with a density of less than 1 float, and objects with a density of greater than 1 sink. So, for your notes, what is the density of water? Question on the left-hand side. The answer here below goes on the right-hand side of your notes. Okay, go ahead and pause this while you write. I'm going to move on. Okay, so summarize here in your notes. You can always write your own, or you can do mine. Okay, try to come up with and create your own definition for density. Describe the molecular arrangement for 2 different substances, one with a high density and one with a low density. Are the molecules or atoms more spread out or more compact? Explain. Okay, describe how you calculate density for an object. Describe 2 methods you could find the volume of a cube. Okay, explain why the density of water is equal to 1. Okay, so go ahead and pause this while you do your summary, okay, and we'll see you in our next unit. All right.